Welcome to Ask and Learn.
All right, guys, we're doing problem 80, chapter 8 of Chemistry Central Science. Based on data in table 8.1, estimate within 30 kilojoules per mole the lattice energy for LiBr, CsBr, and CaCl2. So we don't know the lattice energy for LiBr. So first we're looking at the lattice energy for NaC for the sodium series, and we're going to find the difference in the lattice energy between NABr and NaCl, and then we divide that by difference in energy between NABr and NaI. Sorry, NaCl and NaI. So we're going to see like a proportional shift if in the difference of the energy as we go down the series. If it's since sodium and lithium are similar, then this should work for them. So now we're going to take the we're going to take the difference between lithium and lithium chloride and lithium iodide. So 83.4 minus 730. And then we're going to multiply that by the fraction we have here, which is going to be 0.53, which is going to be 55 kilojoules per mole. Per mole, and then we subtract 8 as the energy of lithium chloride, and we're going to decrease it by 55 kilojoules per mole. And that's going to give us 779 kilojoules per mole. That's going to be the kilojoules per mole of our LiBr. Now we're going to do something similar for our cesium. So let's look at our cesium, get our cesium values here. So cesium chloride. And cesium iodide. So 657 kilojoules per mole. And then 600 kilojoules per mole. So what we're going to do is we're going to take the difference here. We're going to multiply by 0.53. We're going to take difference 657 minus 600 times 0.53. That's going to be going to be 30 kilojoules per mole. Well, then we do 657 minus 30 is equal to 627 kilojoules per mole for cesium bromide. And now we're going to be looking at calcium chloride. So we're going to do a similar operation. So we're going to go back to table 8.1, and we're going to get the values for the oxide series. So magnesium oxide, so we're going to look at magnesium oxide, calcium oxide, and strontium oxide. And then we're going to take those numbers, 3795 kilojoules per mole. Mole, 3144, 3414, 3217 kilojoules per mole. And now we're going to compare it to MgCl2, CaCl2, which is what we're going to find, and strontium chloride. Two, 5, 2, 6. Mole, and 2127 kilojoules per mole. Mole. So then we're going to do the same thing we did here. So we're going to subtract magnesium oxide and calcium oxide and divide it by the difference between magnesium and strontium. Seven. 3795 minus 3414 divided by 3795 minus 3217 is going to equal 0.66. And next, we're going to do these two. We're going to do 2526 minus 2127 times 0.66. Kilojoules per mole. So then we do 2526 minus 263.34. So that's going to be the delta. So that's going to be 1,262.66 kilojoules per mole for CaCl. ACl2.